Now for problem statement number 8, let's see, Johnny is launching a rocket from the Round Rock High football field, and we've got our table of data here. Let's see, graph the function from the table. Make sure to label and scale our axes. So we've got time and height. So once again, we'll put our time in seconds and our height in feet. And let's see, I mean to go to, it looks like my table only goes to 60 or to 6. However, it's not back to the ground yet. So let's see, I've got 10 across. Looks like I should just label by ones. And I might use more than just the 6. We'll see. Let's see my height. I go to 200 and a little bit past, because I know this isn't the vertex, so it's got to go a little bit past that. So let's see, I've got 10 lines. I want to go up to 200. Well, if I did by 20s, here's 20, 40, 60, 80, 100. 20, 40, 60, 80, 200. And then I've still got room for my vertex in there. Okay, I've got 0, 0, 1, 80, 2, 140, 3, 180, 4, 200, 5, 200, and 6, 180. Now it's important to keep in mind that the path of this rocket does not, under any circumstances, just taper off and make a flat line right there. You would never see that in real life. Something goes up and then just hangs out for a little bit and then starts falling down. It's going to come up above and then fall back through, and then follow these exact same path all the way back down. Now, since I know that I have an axis of symmetry that has to happen between, since the thing has to be symmetrical, the axis of symmetry has to be exactly halfway between these 2 points, because they have to be mirrored, which means that I could then reflect all my other points over to find out more information about my graph. Let's see, from here, I'm 1, 2.5 away. So if I go half, 1.5, 2.5, it's got to go there. And then here I am 1, 2, 3.5, 1, 2, 3.5. And here, sorry, let's draw that line. I am 4.5 away, so another 4.5 away will be there. So I was able to use those properties of symmetry just to go ahead and reflect all those points across the table. Now, part B, using the calculator, write an equation that models the above problem situation. Now, this is where we're going to have to use quadratic regression. The way that we do that is by going to the Stat menu in the calculator, and option number 1 is Edit. L1 is where we put all of our x values, and L2 we put all of our y values. So let's put our x values, or actually in this case not x values but t values, our independent variables. Let's put in 0, 1, 2, 3, 4, 5, and 6. Now I want to go in and put my dependent, or in this case my height values, 0, 80, 140, 180, 200, 200, and then 180. Important thing to keep in mind, these have to go in as ordered pairs. You know, here my 3 and my 180 were matched up. Here the 3 and the 180 have to be matched up as well. Also, these two lists have to be the exact same length. If one is longer than the other, you're going to get an error later on that says dim mismatch, which means dimension mismatch. That means that the dimensions of this was longer than the dimensions of this. So make sure that those two dotted lines are next to each other and you won't have that problem. After you have this typed in the calculator, we're going to go back to the Stat menu, arrow right to get into the Calculate tab, and then we're going to use our regression. There's several different options for regression. The one we care about, since this is a quadratic equation, is quadratic regression. Press 5, Back on the home screen, now press enter. And it tells us that we've got ax squared plus bx plus c, which is our standard form for a quadratic equation. But a is negative 10, b is 90, and c is 0. So my equation is y equals, replace that a with negative 10, so negative 10x squared. Replace the b with 90x. And then you can write plus 0 if you want to, but we never have to write plus 0 because it doesn't affect anything. Now for part C, predict at what time the rocket will return to the ground. Well, we've already taken care of that by reflecting these points. So I look over, the rocket will return to the ground at 9 seconds. And once again, that's where our symmetric properties of parabolas, the symmetric property of parabolas is very, very important. D, at what time is the rocket 80 feet as it returns to Earth? Now, you'll notice that it passes through 80 two different times, here and here. But the first time, at 1 second, it's going up away from the Earth. And at 8 seconds, it's coming back down towards. So we're looking for this one. So that is at 8 seconds.